Hello students, welcome back to maths class. So today we will solve some more problems from definite integrals, right? So almost now we are using the formulas, that means from the integrals we are using the same formulas, integrals, then definite integrals. Almost we are at the end of the chapter. So just by seeing the problem you will get the idea which formula we have to take and how we have to solve these problems. Okay, so come to the first one. Observe what is that. It is a to b, integral a to b f of x dx form, isn't it? So you take the given integral as I is equal to integral pi by 6 to pi by 3 root of sin x, okay, by root sin x plus root cos x dx. You consider this as your first equation. Now, which formula we have to use? A to b, two limits are there. Generally 0 to a, much used formula in this chapter is 0 to a. Now this is a to b type formula, isn't it? Limits are a to b. F of x dx is equal to which formula we have to take? A to b. Already we used once in that cos x by 1 plus e to the power of x problem, isn't it? So we can take this as a plus b minus x into dx. Lower limit plus upper limit minus x into dx we have to take. So come on, I is equal to integral pi by 6 pi by 3 root of, in x place we have to take sine of a b. Your a b are pi by 6 pi by 3. So pi by 6 plus pi by 3 minus x, okay, by root of sine of pi by 6 plus pi by 3 minus x plus same thing cos of pi by 6 plus pi by 3 minus x, okay, a plus b minus x form, a plus b minus x form into dx. Okay, so now take the LCM, pi by 6 plus pi by 3. Okay, so what is the LCM? 6 is the LCM. Okay, so now how we can take these values? 6 is the, this is pi and this is 3 2s are, right? So this is 2 pi, so is equal to 3 pi by 6. 3 1s are 3 2s are. So it is pi by 2. So is equal to integral pi by 6 to pi by 3 root of sine, come on, it is pi by 2 minus x by root of sine of pi by 2 minus x plus root of cos of pi by 2 minus x into dx. Pi by 2 minus x means first quadrant 90 minus x. So in first quadrant all are positive and 90 plus 90 minus ratio changes. In this problem we are having 90 minus. Okay, so it is integral, what is that? Pi by 6 to pi by 3 root of, your sign changes to cos. So it is cos x by under root of, sign changes to cos, cos changes to sine. Why? It is 90 minus theta, okay, sine x dx. You consider this as your second equation. Now you add two values, 1 plus 2. So what happens? It is 2i is equal to, observe what is the I, first equation. So see the limits, pi by 6 to pi by 3. So here also it is pi by 6 to pi by 3. So whenever both are having same limits we can write combinedly. So it is pi by 6 to pi by 3. We can write combinedly the values, that is root sin x by root sin x plus root cos x. Okay. Similarly, plus root of cos x by root of cos x plus root of sin x into dx. Okay. So, is equal to integral pi by 6 pi by 3. What is the LCM? Right? Both are having same, right? So, root sin x plus root cos x is the LCM, and upwards root sin x plus root cos x into dx. So, both will get cancel. What is the leftover value? Dx is leftover value. Pi by 6 to pi by 3 to pi by 6, or pi by 6 to pi by 3? Pi by 6 to pi by 3. So, integral dx is x, and limits we have to write right side pi by 6 to pi by 3. Now, in x place, first upper limit pi by 3 minus lower limit pi by 6. What is the LCM? 6 is the LCM. So, it is 2 pi minus pi is equal to pi by 6. So, 2i is equal to pi by 6, but we want I value. Why I value? We have taken the question as I in the beginning. I is equal to this one. So, our question is I. So, we have to get at the end, we have to get I value. So, I is equal to, send this to that side. So, it is pi by 6 into 2, that is 12 is the answer of your question. Okay, this is your first question. Come to the second question. What is your second question? Integral, find integral 0 to 3, right? X by root of x square plus 16 into dx. Okay, so already I said to you, whenever any value is under square root, you consider that value as a square. Okay, so you take this square, the value which lies under the root as t square is equal to x square plus 16. Okay, so now differentiating with respect to x on both sides of the equation. So, come on, d by dx of t square is equal to d by dx of x square plus 16. So, what happens is equal to, this is x to the power of n form, n into x to the power of n minus 1 into d by dx of x will be there. So, 2 into t to the power of 2 minus 1 into d by dx of t is equal to, we can take this as d by dx of x square plus d by dx of 16. Okay, so we can take this as 2t dt by dx is equal to 2x plus derivative of number is 0. So, we are having 2t dt by dx is equal to 2x, 2 cancels. So, now your problem is in terms of t, isn't it? Under root of x square plus 16 is taken as t square, and even our dx value, right? You take x dx and this dx that side, what happens? This is t dt is equal to x dx. Even our x dx is in terms of t dt. Now, your entire problem is in terms of t, isn't it? So, we have to change the limits also. Indefinite integral, if we go for substitution, if we change the problem in terms of t, we have to change the limits also in terms of t. Okay, so come on, upper limit. So, how we will take, limits are given with respect to x. x is equal to 3 is the upper limit. Now substitute in this equation. T square is equal to x square plus 16, that is 3 square plus 16 is equal to 9 plus 16, that is 25. So your t is equal to 5. Similarly, you take your lower limit. So what is your lower limit? X is equal to 0. Substitute in this equation. T square is equal to 0 square plus 16 is equal to 16. So how we can write this value as 4 square? Here also we can write 25 as 5 square. Therefore your t is equal to 5. Here t square is equal to 4 square. Therefore your t is equal to 4. Now your limits also in terms of t. Okay. Now you take your original problem 0 to 3 x by root of x square plus 16 into dx. X dx we got it as t dt, isn't it? And what are the limits? Right, with respect to x 0 to 3, with respect to t the values are 4 to 5, upper limit is 5, lower limit is 4, by root of, what is this? This value is t square. So square root cancel, so 4 to 5 t dt by t, tt cancel. So integral dt is t, okay, and it is 4 to 5. Right side we have to write the limits. After taking the formula, right side we have to write the limits. Now in t place, first upper limit minus lower limit, that is 1. So that is your answer. Okay. So this is your second question. Now come to the third question. Observe the question carefully. So while solving, before solving the problem, observe the question and read the question 2 times, then you start solving the problem, right? So come on, come to the third question. What is the third question? Find the integral 0 to 4 x square by 1 plus x into dx. Okay. So there is no direct standard formula for this. So whenever it is not like that, we have to reduce into our formula form. How we can reduce it? So just adding and deducting. So here first we will deduct. Why we have to do like this? In next step you will know it. So first I am deducting, then adding by 1, deducting and adding 1. Okay, whole divided by 1 plus x into dx. You consider this as one part, right? So now it is of the form, which form? A plus b by c, isn't it? So what I said, whenever it is like that, we can write this like this. Two integrals we can write, we can separate. So same thing here we will do. These integrals are 0 to 4. So 0 to 4 x square minus 1 by 1 plus x plus integral 0 to 4 1 by 1 plus x into dx, right? Okay. So same thing, it is 2 terms upwards. So we can write separately. So again this 1 can be taken as 1 square, isn't it? 1 square is 1 only. So now it is of the form a square minus b square form. So a plus b into a minus b. So we can write x plus 1 into x minus 1 by 1 plus x. Okay, integrals are 0 to 4 dx plus integral 0 to 4 1 by 1 plus x dx. So 1 plus x plus 1 cancel. That's why in this problem first we deducted, then we added, deducting 1 and adding 1, so that it will be in the form of a square minus b square, so that we can write a plus b into a minus b. So we can cancel x plus 1, 1 plus x. Okay, now you take the integral for this. So x minus 1 we can take separately. So how we can take 0 to 4 x dx we can take, and minus 1 into dx means minus can be taken outside and it is integral dx. Okay, and this one is nothing but log of 1 plus x, and we will take the integrals 0 to 4. Okay, so is equal to x to the power of 1 you can write. If power is not there means to the power of 1. So it is of the form, which form? Integral x to the power of n into dx. So n plus 1 by n plus 1 is the formula. So here x to the power of 1 plus 1 means x square by 2 minus integral dx is x. Once we apply the formula, we have to take right side the values, isn't it? 0 to 4 limits should be taken on right side. I think you are perfect with all these things. Once we apply, we have to take the limits right side. After that, in x place, we have to substitute the upper limit, minus in the function in x place, we have to substitute lower limit. Okay, so it is 4 square by 2, 0 square by 2, minus 4 minus 0. Next, plus log of 1 plus 4 minus log of 1 plus 0. In the function, wherever x is there, first upper limit, minus in the same function, wherever x is there, lower limit. Okay, so is equal to, what is this? 16 by 2. Okay, so this is 4 minus 0, minus 4, plus log 5 minus log 1. So is equal to, this one is 8. 8 minus 4 is 4, plus log 5. Log 1 is 0. So 4 plus log 5 is the answer of your question. Okay, so very simple, but the thing is, first the given problem is not in our standard formula form. If it is not in standard formula form, we have to reduce it into our formula form. How we can reduce it? By deducting minus 1 and adding 1. So after deducting minus 1, it will be in the form of a square minus b square form, a plus b into a minus b, so that these two terms will get cancelled. Generally, first we will add, then we will deduct. But in this problem, first deducted. Why deducted? So that it will be in the form of a square minus b square. So I can write that as a plus b into a minus b. Okay. So now come to the fourth question. What is your fourth question? Observe the limits, and with that you will know which formula we have to apply. 0 to a form, isn't it? In a place we are having pi by 2. So come on, we will take that problem. Which problem? Problem number 4. So you take the given question as I. So that is 0 to pi by 2 a sin x, a into sin x plus b into cos x divided by sin x plus cos x, okay, into dx. You consider this as equation number 1. So which formula? Most repeated formula, 0 to a f of x dx. In these definite integrals, almost 10 to 12 times we used this formula, right? So what is that? 0 to a f of x dx is equal to f of a minus x into dx. So come on, now apply this formula. I is equal to, in a place we are having pi by 2. So a sin x plus b cos x, okay, divided by sin x plus cos x into dx is equal to integral 0 to pi by 2 a into, wherever x is there, there we have to take pi by 2 minus x. So come on, we will write a into sine of pi by 2 minus x plus b into cos of pi by 2 minus x divided by same wherever x is there pi by 2 minus x. So cos of pi by 2 minus x into dx. 90 minus theta. So first quadrant all are positive, all ratios are positive, but 90 minus theta ratio changes, sin changes to cos, cos changes to sin. This is your I 0 to pi by 2 a into cos x, sin becomes cos, cos becomes sin, sin x, okay, by this will be your cos x plus sin x into dx. You consider this as your second equation. Come on, what will be the next step? Adding 1 and 2. So I plus I, it is 2i, and observe the limits of both I, both are having same limits. Whenever it is like that, what I said, we can write the values combinedly. So come on, it is a sin x plus b cos x by sin x plus cos x plus a cos x plus b sin x by cos x plus sin x into dx. Observe, what is the LCM? Both are having same value, that is your LCM. So 0 to pi by 2. What is your LCM? It is sin x plus cos x. Upwards, observe carefully, a sin x plus b cos x plus a cos x plus b sin x. So sin x term is repeated 2 times. Cos x term is also repeated 2 times. So we can take common now. So is equal to 0 to pi by 2. Taking sin x as common, then what happens? A, and here also sin x term is there, that is b. Similarly, taking cos x term common, if we take cos x term common, then what happens? Here a is there, here b is there. A plus b by sin x plus cos x into dx. So from these two we can take a plus b, right? So if we take a plus b common, then we are having sin x plus cos x by sin x plus cos x, okay, into dx. These two will get cancelled. So what happens to our value? We can take a plus b outside, right? What are the limits? 0 to pi by 2. So leftover is dx only, 0 to pi by 2. Integral dx is x. So is equal to a plus b into x. The limits are 0 to pi by 2. So come on, in the limits we have to substitute, in x place we have to substitute upper limit minus lower limit. So what is your upper limit? Pi by 2. What is your lower limit? 0. Pi by 2 minus 0? Pi by 2. So it is a plus b pi by 2 is the answer of your question. Okay. So this is your fourth question. So be careful, whenever 0 to a is there, maximum we used that formula 0 to a f of x dx is equal to 0 to a f of a minus x into dx. Okay. If you substituted, you will get another I. Just add them and try to get your I. Okay. So this is your 2I, isn't it? So now you find out your I. At the end we have to find I value. So I is equal to, send this to that side. What happens? A plus b, pi by 2 is there. 2 into 2, 4. That is the answer. So be careful, don't stop at 2i. We need I value. Why? We have taken the question as I. So after finding 2i, we have to send this 2 to that side. Okay. So that's all for today. Have a nice day.